Longitudinal reinforcement. Now we can see the shear reinforcement display design info. So here in the output we can see longitudinal reinforcement rebar percentage apply. So here in each member rebar percentage is showing. The software basically show the reinforcement at 3 locations in each member, 1/3 and 1/3 to 2/3, 2/3 to and at 3/3 position. So let's check shear reinforcement apply. So here is showing 0 0. Okay, so at the end of the design there are 2 checks. Verify all members passed. So it's showing all members have been passed successfully. The last condition is verify analysis and design sections. So here analysis and design section differ for 16 concrete members. Do you want to select them? Yes. So here are the members which are different. Analysis section are different and design section are different. So for that purpose we have to make some changes. So I am going to make some changes, like I am applying here. Let's check what are the members here. Summary. So currently here is a beam 450 by 600. So I am going to apply here a stiffer member. So I have selected and I am going to select the center one so that my perimeter beams become stiffer. So I am going to assign frame section property. I am going to assign 600 by 1100. Apply. Okay, the rest of the beams are in the under auto select beam. So but the perimeter beams are now in the condition of high stiffer members. Now I am again going towards the analysis and design. First I have run the analysis. Then going back towards design. Here now only 4 members are differ from the design and analysis section. It is taking time, but don't worry. After performing reiterations, it will show. Now we again going towards the verify checking. Verify all members have been passed. Okay, verify that all the design analysis section are same. So now analysis and design sections match for all concrete members. So for study purpose I have just shown that we can change the arrangements to pass our members. So that's how we did. So now after designing we can study more, like I am going to check this member by right clicking. So its location, for example the member is designed against this combination and the bottom steel is this, and shear reinforcement now needed. So let's check in this summary. So this is the beam, this is the section, this is section properties BH, and material property EC24 and FC prime FY. What are the design code parameters? And here is design moment. So the positive moment is 1948 kilonewton meter. So against that the positive rebar is 6925 millimeter square. So any person calculate the number of rebars, like he may select number 25 bar, number 32 bar, and after that he can calculate the number of bars. Similarly in the shear and the torsion. So there is no requirement of shear in this beam, so definitely we will provide the minimum steel of shear reinforcement flex checks in any other member. So in this member, again in this member summary, so there are many members in which shear reinforcement is not required. Let's check in the the column members summary. So here in the column, again only the friction reinforcement is present. So okay, so we have successfully analyzed and designed our members. Now we will go towards the designing of the slab and of the foundation. Now for the designing of the slab and the foundation, we will export the slab app into the SAFE software. Here is CSI SAFE software. So now I am going to do export in the SAFE. So first of all, for the designing of the foundation, I will export all the column slots, etc. Live, okay. Select the load combinations, okay. Okay. So here, foundation and slab design. First of all, foundation design only. Here, foundation, save. Now I will explain. Now up till now I have only exported the foundations. So now I am export the slabs. Basically put all the story level to file, export story level 2. On that story there is all the slabs are present. So I have selected all the loads. I am clicking OK. So I will again create new folder for slab design. Click OK. In this I will slab, save. After exporting, now I will close my model and open the CSI SAFE software. After opening the software, I will import SAFE model. So basically my SAFE model is present in the folder foundation design. So this is the exported the location where I have exported our foundations. So I am clicking open, selecting the model. So this is the grid system as we have seen in the ETABS software. So at each column foundation we will provide the spots, foundation slabs, etc. For example, I am going to define the material. So here is already defined CSA. I am going to define new material. I call 28 megapascal of concrete material. Here is modulus of elasticity. Here is the 30 megapascal. I am going to define 28. Okay. After defining, I will define slab section. Slab there is already defined. I will just modify it. It's a 200. I will define 600 millimeter foundation depth slab. So select the material 28 megapascal. Okay. After that I will just draw the slab. Here is a quick draw slab areas. Here is again quick draw area around 8 points. I will select quick draw slabs. I think this option is good. I will select 2 meter width by 2 meter length foundations. Now I am going to draw here one foundation here, here, and here. So So these are the foundations at where our columns are present. We can check the loads. For example, I am clicking here and right click. Here I can check the loads. The loads are successfully imported from the ETABS software. Dead above, dead live. Okay. So after defining, I am going to define the boundary condition. For boundary condition, let's suppose we have the soil capacity 200 kPa and allowable settlement 1 inch, which is equal to 25 millimeter. So to make the stiffness or the spring constant, K is equal to 200 divided by 25, 0.025. The answer will become 800 kilo Newton per meter cube. Kilonewton per meter cube. Meter cube. So here I am going to define the soil subgrade properties. It is already defined. I am going to define the new property of soil. So in our case it's 8000 soil capacity divided by bearing capacity divided by allowable settlement. Here is our soil 200 megapascal. I am clicking OK. Now after that I will select all the slabs, foundation slabs, and assign spot data soil properties slab to 200 GPa. Okay, so under each boundary conditions is defined successfully. Now I will define the load combinations. Here is a load pattern, again dead, live, etc. So I will just select the load combinations. These are the load combinations. For the design of our foundation, we will select the service load combination, so these combinations will not be needed. I will define the combinations just for service normal. Okay, means one dead, one live. Okay, so now after that I will save the model with the foundation design, save. After saving the model, I will run the analysis and design. Run analysis and design. First it will run the analysis and automatically after that it will run the design. Okay, so after that we can see the results like display, show reactions, definitely that will be the same, show slab design, show punching, share design. Like here the applied load divided by the applied loads divided by the slab capacity if it's less than 1, so our punching share is all in all the slabs is okay. Show the slab design. So for the strip base, now we will check the FEM, finite element design, top rebar, apply. Here we can check on each slab what is the top rebar. So there is much more reinforcement, millimeter scale per meter. At the center there is less, and as we going the away from the center there is much more required in the one direction. So let's check in the two direction, apply. Again in the top also require much more reinforcement. Let's check in the bottom. The bottom is 2000 millimeter scale, in the 2 direction, apply. So basically in X direction top and bottom, in the Y direction top and bottom we have checked by FEM method. Apply how much reinforcement is required. Now we will check by strip method. By strip method checking we have to define the strips. So let's add it, add design strips, or you can draw design strips, draw design strips. So here for example I am defining from here to here, enter. Second from here to here, enter. First I am defining in the Y direction. Okay, now I will define in the X direction. Here now we have defined the X direction strips and Y direction strips. So let's check again, run the analysis and design. Okay, display, show slab design. In the slab design now we can check the strip based. So in the strip base we can showing the top and bottom rebars, apply. So here when for example let's check, it's a more simple one here, this in this strip. So here at the top reinforcement requirement, and this is in the X direction. Okay, this is the both top and bottom. Let's check only top, apply. So here is showing the top. Let's check only bottom. So what are the reinforcement in this? Now we are checking the bottom, top and bottom in this direction also, apply. Okay, now I will again save the model. Basically we have also designed successfully our foundation. Now I will design the slabs. Okay, basically I will again import. Now I will go into not foundation design, the slab design. Here is the TV studio, open. When will I open? Now it's in the new window. Now I can see in the 3D. So these are the columns, this is the slab, and this is the boundary conditions which are showing this. Under these are the columns. So for this purpose, we have to also define the I have to define the strips. So edit design strips, add design strips, for example in X direction and strip layer A. Okay, so here you can see now again design strips in the Y direction, now in the Y direction by label B. Okay, you can see also. After finding these, let's define the load combinations. So there is already load combinations are present, that's good. So for the slab design we have to must check for the ultimate load, so that's why we have selected the 1.4 dead and 1.2 dead plus 1.6 live combinations. Now each and everything is defined successfully. Now I am going to save the model in the slab design folder, TV studio slab design, save. After saving I am going to run analysis and design. It is showing the deform shape displacement dead millimeter against the red load. So we will check the slab design, show slab design. So we can check the reinforcement just for top rebar in the layer A, apply. Here you can check the top reinforcement only present at the spot, and in this spot, okay, Now in the B direction, apply. So here you can also see, basically it's showing the top and bottom. That's a good thing in the one time. Okay, so now we can also see the detailing. Now after I am going to run the detailing, so we can check the reinforcement bars in each slab also. Run detailing. It will just take few seconds and generate the drawings. So here this is the drawing list, what type of drawing is generated. Slabs, beams, properties, data. So let's check the slab views. This is the framing plan, this is the rebar schedule, quantity is showing less. So here is basically slab. This is showing the slab views. This is basically individual slab views, like slab 1, which is we have defined the 200 millimeter slab. So this is the showing the rebar plan of all top, bottom, x and y. So for the top rebar plan, here is only top rebars. For example, we can see in detail, for example here, from this space to this, and what are the notations you can check in the general drawings. So for example, here this section, for example, first of all check what is the sections here. One section is here and one section is here. So let's check, this is section 2, so let's check section 2. So here in this lab is showing section top reinforcement on the spot and bottom reinforcement passing, and again top reinforcement at this spot. Let's check in this section 1 here. See the reinforcements. So that's all for the slab design. For the more details you can check in the in the documentations. You can check the manuals, like here are the verification manuals, design manual, reinforcement concrete, all tutorials etc are present. You can also visit YouTube for more videos on the slab design. So thank you, that's all. Allah Hafiz.